This video is going to start on the basics of truth tables and how you fill them out. There are three main operations you're going to be dealing with here between two statements P and Q. This first one here, this symbol means P or Q. So whenever you see this symbol in math, it means the English word or. This symbol here means P and Q. So this symbol means and. Kind of makes sense. You see this, it looks like a capital A for and. Only problem is this capital V doesn't really tell you or at all, but whatever, as long as you can find someone to remember which one's or, which one's and. The third and final operation we're going to really worry about is this one, which is a little bit harder to understand. It translates into P implies Q. Another way of saying that is if P, then Q. And finally, if I want to try to break this down to a little bit more understandable, it also means whenever P is true, we must also have Q is true. Okay, so let's see how we fill out the truth tables. For this first one here, we have P or Q. Or means that as long as at least one of P and Q is true, then the combination P or Q will also be true. So you just have to look at the row and see, is there at least one true? If there is, then you're guaranteed that the overall result is true. However, if you have a row that has no trues, that means P or Q are both false. That means it has to be a false answer here. For the next table, we want P and Q. And it's completely the opposite. The only time that P and Q is true is if both P and Q are true at the same time, and that's only going to happen once right here. So true, true gives us true, and everywhere else is going to give me false. Because again, those all three rows do not have both P and Q being true. And again, this third operation here is a little tricky one. So the easiest way to think about it is this last part here. And it says whenever P is true, we must also have Q is true. So if you look down here, the last one is true, true. That would definitely be true because we have a case where P is true and we therefore also know Q is true. We're good. However, the next row up, we have a case where P is true but Q is false. That would not match this equation here, this sentence, and so therefore this has to be false. Now these last two rows are where people usually mess up the most on. Notice that this sentence says whenever P is true, we must also have Q is true. The thing is, in these first two rows, P is false, and this sentence doesn't actually say anything about when P is false. And so it's not violating this condition here. And so what that means is the answer is true. The easiest way to remember this is that whenever you have a P implies Q statement, it's always going to be true except for the one time where P is true and Q is false. And that's how it's going to give you a false there.